Welcome back to another great section of this wonderful tutorial class. Today we are going to be looking at the topic kinematics. And this is the first class on this topic. Please ensure you watch this video to the end, and please don't skip any part of this video. Don't skip any part of this video, and please ensure you subscribe to this channel. As you subscribe, then we'll have more energy to do more videos. Please, let's go into this topic now. Kinematics. Now, what is the meaning of kinematics? That's the first thing. What is the meaning of kinematics? Now we have a topic in physics called motion. In the topic in physics called motion, we have type of motion. We have linear motion. Now, actually, we want to look at linear motion now, then kinematics of a linear motion. That's what we're looking at now. Now, kinematics is a branch of mechanics that studies motion. Just motion is like a change of position of a body. Now, when I study this change of position of a body, without taking regard to the forces causing this change of position, then we call it kinematics. We call it what? Kinematics. So, kinematics is the study of motion without regard to the forces causing the motion. The study of what? Motion without what? Regard to the forces causing the motion. Now, the motion of an object can be described by the following. We can describe the motion of an object by the following. Number one, we can take the displacement of that object or the distance of that object. Now, displacement is defined as a distance moved in a specific direction. One of the major difference between displacement and distance is that displacement is a vector quantity, while distance is a what? It's a scalar quantity. So displacement can be presented in one dimension, and as a two dimension, and as a three dimension. Remember, vector has one. You can have vector in one dimension, vector in two dimension, and vector in three dimension. If you know you have not looked at or you have not watched our video under vectors, please go back and do so. What about velocity? We also have velocity. To this, if you want to describe the motion of an object, you can say what is the velocity of that body, what is displacement move. Let's say a body was here. It now changes its position to this place. We can ask you what is the difference between this and this, which is the distance between them. If the direction of the distance is known, we call it displacement. We can also ask you what is the velocity of this body when it moves from here to here. And what is velocity? Velocity is the displacement moved divided by the time taken to take that displacement, or the rate of change of displacement. That is velocity. The rate of what? Change of displacement with time. So when you measure this distance moved divided by time, that velocity that associated with distance is called speed. That's what we call that one. So distance moved divided by time is called speed. Displacement moved divided by time is called velocity. Take note of the two, very important. Velocity is a vector quantity, but speed is a scalar quantity. So velocity V is equals to change in displacement, let's say arrow, over change in time. So you can say displacement over time is called velocity. So velocity is actually displacement divided by what? Divided by time. What about speed? I will explain speed later. Let's do velocity now. Let us explain velocity in degrees. Now, putting this definition in using calculus or differential calculus, putting this or rewriting this expression, which is the change in arrow by change in time, using differential calculus, we say velocity will be equal to the differential coefficient of displacement with respect to time. And this differential should be as a function or a function of time. It will be as a function of time. Being something like a function is being a function of time. The differential should be a function of time. So the arrow over the t is called differentiation of arrow with respect to time. That's the meaning. Differential of what? Arrow. Respect to what? Time. It's called differential calculus. Differential calculus. Then when I ask you, what is arrow? When velocity is given as a function of time, then the arrow is the displacement will be equal to integration. This one is integration calculus of velocity with respect to time. Think of this definition. Very important. Why velocity is equal to duration of arrow with respect to time, or derivative of arrow with respect to time, then arrow is displacement to take note of that. Arrow means displacement. Then if I was asking what is displacement now, if velocity is given as a function of time, displacement is equal to the integration calculus of velocity related to time. Integral v dt. Now what about speed? What about speed? Speed is equal to distance over time. Or just distance, let's say d over t, high speed. Our speed is equal to the distance over time. Or you can say differentiation of distance with respect to time will also give you speed. You differentiate distance with respect to time will also give you speed. If you integrate speed with respect to time will also give you distance. Remember, speed will not have direction. The difference between this speed and this velocity is that velocity has direction, but speed does not have. Speed only have magnitude, but no direction. Take note of that. They also have acceleration. There's also called something acceleration. Remember, we use all this to describe the motion of an object. That's what is the acceleration, what is the velocity of the body, what is the distance moved or the displacement, and so on. Now, what is acceleration? What is acceleration? Acceleration. Now, let me use A. Acceleration. Let me just acceleration A. Acceleration means the rate of change of velocity with time. Rate of change of velocity what? Relative to time. Or velocity over time t. Over time t. So the rate of change of velocity or the change of velocity relative to time is called acceleration. When you are changing your velocity with time, you are developing something called acceleration. So if you want to write this in differential calculus, we can say, acceleration will be equal to the relation of v relative to time. Relation of v relative to time. So if you have velocity given as a function of time, and they are asking what is acceleration, acceleration will be equal to the relation of what? Velocity relative to time. And if I give acceleration as a function of time, say what is velocity? Velocity will also be integration of acceleration with respect to time. Think of that. Just we have this displacement to be equal to integration of velocity with respect to time. Now, if this one is speed, and this one is distance, distance will also be equal to integration of speed with respect to time. Think of that. It's also applicable for that. So velocity is also the same thing as integral A dt. I'm going to show you how to run this mathematics. It's very simple. Just follow me and show you what the class will end. Everything is very simple. Don't worry, I'm going to explain everything. I'm going to solve problems under this stuff you are seeing there. I'm going to show you how to use all these symbols, differentiate, integrate. They are very simple. Now, let's now assume velocity is given as a function of displacement. As a function of displacement. And they're asking you what is the acceleration. If velocity is given as a function of displacement, and they're asking you what is the acceleration, acceleration will be v dv over dx, where x is equal to displacement. Displacement in meters. Where x will be our displacement in meters. So if V is not given as a function of if V is given as a function of time, if V is given as a function of time, acceleration will be dv over dt. But if V is given as a function of displacement, acceleration will be equal to what? V dv over ds, where s is the what? Displacement. Take note of that. Very, very important. Very, very important. Follow me. Where V is velocity, dv over ds is the differential coefficient of velocity relative to time. Question. Let's look at this question. Follow me. Let's look at this question. Let's look at this question. Let's look at this question. The velocity of a body is given as a function of displacement. The velocity of a body is given as a function of displacement according to the law. V is equal to 6x. According to the law, V is equal to 6x. Where S is in meters. Where S is in meters. The velocity of the body, take down. The velocity of the body is given as a function of displacement. According to the law, V is equal to 6s, where S is in meters. Calculate the acceleration of this body. Calculate the acceleration of this body. Calculate the acceleration of this body at a displacement of x equal to 60 centimeters. At a displacement of x equal to 60 centimeters. At a displacement of what? S equal to what? 60 centimeters. At a displacement of s equal to 60 centimeters. Let's go. Solution. They say, what is the acceleration at the displacement of s equal to 60 centimeters? I told you, if velocity is given as a function of displacement, what is the acceleration? V over ds. So acceleration will be V, which is velocity, times what? dv over what? dx. Now, how do you differentiate? What is the meaning of dv over ds? It means differentiating V. How will you differentiate? How do we differentiate? Now, all these are simple polynomial functions. All these are simple what? Polynomial functions. And if I want to differentiate a polynomial function, I'm going to differentiate it as follows. Look at it. I'm going to look like this. Let's say I have y as a function of x. And so what is dy over dx? So that we have v as a function of x. I'm asking what is dv over dx. Something like that. If y is ax, if y is equal to ax raised to power n, dy over dx will be n times a. Use this part to multiply the coefficient which is n times a. Then you rewrite the x again, remove 1 from the power. That will be the differential coefficient of that. If I have just a times x, and I'm asking you, what is the differential of ax? Then if you differentiate ax, s will disappear, only a will be there. If I differentiate 6x, s will disappear, only 6 will be there. That's the meaning. I'm still going down. If I just have x, I'm differentiating related to x, so remember. And I said differentiate related to x, the answer will be 1. Since it's just x, without the coefficient, and the power is 1. If the coefficient is 1, power is 1, differentiate it, the answer is 1. What if I just have a number, let's say a, without x that I'm differentiating related to? The answer will be 0. Take note of that. Very, very, very important. Take note of that one, very, very important. So, remember, from the question, v is equal to 6x. This v is equal to 6x from the question. Now, what is not dv over dx? How will you differentiate 6x? Remember, I said if I differentiate ax, if I differentiate 3x, the answer will be 3. Differentiate 9x, the answer will be 9. Why? If I differentiate ax, the answer will be 8. Take note of that. So, if I differentiate 6x, the answer is going to be what? The answer is going to be 6. So, I'm going to have answer. So our acceleration will now become v, which is 6x from the question, times dv over the which is 6. That will be 36x. 6 times 6, that will be 36x. Now at s equal to 60 cm, that is 60 over 100 in meters. When we go from centimeters to meters, divide by 100. This one gives us something like 0.6 meters. 0.6 meters. Or 6 over 10 meters. 6 over 10 meters. So, our acceleration now at s equal to 60 cm or 0.6 meters will become 36 times 0.6. What will this one give to us? Calculator is going to give you 21.6 meter per second square. The unit of acceleration is meter per second square. Velocity is in meter per seconds, then the difference is in meter times the seconds. So please take note of all this definition before I wipe the board. I want to solve another question now. Take note of all this definition. I want to wipe the board now. Take note of all of them. Take note of everything there. Very, very important. Now take this question down. Take down this question. A position vector. A position vector is given in space as arrow source with t equal to t square I plus 3tj plus t raised to power 3k. T square I, position vector, is given in space as arrow source with t is equal to t square I plus 3tj plus tqk. Obtain the velocity and acceleration. This is the displacement of the particle. Obtain the velocity and acceleration at t equal to 5 seconds. Obtain the velocity and acceleration at t is equal to 5 seconds. At t is equal to 5 seconds. And also obtain the magnitude of velocity and the acceleration. Obtain the velocity and acceleration, and also obtain the magnitude of velocity and acceleration. So we have to obtain the magnitude of velocity and acceleration at t is equal to 5 seconds. So let's go. Let's go. We're going to have velocity to be equal to, remember the velocity is equal to the value of t, the arrow over what? Over the t. Now to calculate something that I told you what you need to do there. Use the part to multiply the coefficient 2 times t will give us 2 times t, then 2 minus 1. I'm going to explain that. Then I plus, if I differentiate 3t, I differentiated 3x, or differentiated 6x, that was 6. If I differentiate 3t, that's how I'm done with t. The t will disappear. Remember to t, and this method we're now having t instead of x. The same thing. Then j plus, what about t raised to power t will be 3 times t, then 3 minus 1, remove 1 from the power, 3 minus 1. Now you have a raised to power n times n minus 1. Then I'm going to have something like 2ti plus 3j plus 3t squared k. This will be the velocity. Then, at t is equal to 5 seconds, the velocity will be equal to, anywhere you see t, you put 5. Alright? Plus 3j plus 3t, that is t is 5 square k. So this will give us 2 times 5, that is 10. Alright? Plus 3j plus 3 times 25 plus 5 square 25 will give us 75k. So I'm going to have 75k. Then this is the velocity at t is equal to 5 seconds. This will be the velocity. Then the magnitude and direction. Then what's the magnitude of the velocity? Remember I told you the magnitude of the vector. Take the square root of the government of r, square it, So the equation of j square it plus the equation of k, then square it. So if you do this, what are you going to have? For the calculator, then you'll be having 75.72 meters per second. That will be velocity. What about acceleration? Acceleration is equal to dv over dt. If velocity is given as a function of time, velocity is a function of time, not a function of s, which is displacement. So let's differentiate velocity. Now, this is velocity as a function of time, which is 2ti plus 3j plus t squared k. So what if we measure 2t now? What we are differentiating here? Our velocity is equal to 2ti plus 3j plus 3t squared k. T squared k. So differentiating this one, our a will be differentiating 2t. We have t, that is we have 2. The t will subtract because we have power. Then differentiate t 0 because it does not have t. There's no t here. Differentiate anything that don't have 1, differentiate 2 to be 0. Differentiate 3 here, because it don't have t to be 0. J. Differentiate 3t squared to be 2 times 3 and 2 minus 1 k. That is going to give us 2r 0j plus 6t this one 1 k. Then at t is equals to 5 seconds, our a will be equal to 2i plus c times 5 k. That will be equal to 2r plus 30k. That's what I'm going to have. I'm going to have that. Then, what about the magnitude of a now? Square root of 2 squared plus 30 squared. Give us an answer. So what will be the answer to 30 plus 1? Alright, we have another question now to solve. The question is, determine the magnitude of the velocity and acceleration in the equation x equal to a sine wt, then y is equal to a cos wt. W is omega, then t is time. It's omega t. The angle is omega t. So what will be the magnitude of velocity and acceleration? What is the displacement in the x-axis? This will be the displacement in the y-axis. So that this is in the s, displacement is in the y-axis when you resolve them. Then the velocity will be, final velocity here will be velocity in the x-axis, then the I will be for the x-axis plus velocity in the y-axis, then g. Now remember, velocity is, if you differentiate this displacement, so that will be something like dx over dt I plus dy over dt. So this one is when you differentiate this related to time. This one is when you differentiate this other related to time. That's what we have. Here is s and y. This is going the s, going the y direction. Then this is just the components of the displacement, the s and y direction. So if you differentiate this one now, related to time, we will have velocity in the s direction. If you change this one related to time, we will have velocity in the y direction. So we are asked to look for the magnitude of the velocity and acceleration. So let's look for the velocity first. Now how we go to differentiate this? Now I'm differentiating this first one. And how we go to differentiate this? So simply take all of this, If you have y to be equal to sine t, and you differentiate this one, it will be cos t. Then you have y to be equal to sine a number, let's say wt, or let me just use arbitrary number, let's say 80, or ax, let me just use ax. The y over the x will be this fx for you take cos of ax. That's how to do it. It's a very simple thing. It's a very simple thing. So if I have y to be equal to, let's say sine w times t, and I ask what is the y over the t. What you will do, you have to take the question of this t. As far as that t does not have power, Or you just differentiate WT with respect to T, that will be W first. Or you can go to chain rule. In this actually, there's one chain rule there. There's one differential calculus class there, and it's already this chain rule. So look at the chain rule solve there. The thing is still there. What you just do there, you take this constant because this is the variable here now, because I'm related to T. This is the variable. So if I take this constant, then if you differentiate sine, you're going to have cos, then you have WT. That's how you do it. Just repeat everything there back. That's how to do that. What about if y is equal to cos t? What is the y over the t? It will be minus sine t. So I'm going to have minus sine. That's the differentiation function. To differentiate sine, you have cos. Differentiate cos, you have minus sine. Then what about if you have y to be equal to cos wt? What will be the y over the t? Remember we have minus for sine. We differentiate cos. You have minus. Then differentiate wt. We're going to have W first. Differentiate cos, you're going to have minus sine WT. Because this one will be here, it will remain the same. Or let's say we have y is equals to sine 3x. What is the y over the x? What do you have to do? Differentiate 3x, you have 3. Differentiate sine, you have cos. Then repeat that 3x. So that's what I'm trying to say now. If you have y to be equal to, let's say, cos 5x. I said this one, as far as that doesn't have power, the answer must be, differentiate cos now you have minus this 5 sine 5x. Or you do it this way. You differentiate 5x, you have 5. Then differentiate cos, you have minus sine, then you repeat this 5x. That's how to do it. So please take note of that. It's very, very important. Very, very, very important. So let's look at this question expression of now. So if you differentiate, try and understand the importance. Differentiate a sine WT. That a doesn't even have any business here because I'm very going to take. So a will be a constant, the a remain there. Then let's differentiate sine WT. So if I differentiate sine WT, remember I'm differentiating the level to t. Differentiate WT, t will disappear, only W will be left there. Differentiate sine, you have what? Have cos. Then the WT will be there. A will not be touched. A will not be touched because A is a constant number. Then I plus differentiate this one. A is a constant, now nothing will be there. Nothing when you see. Differentiate WT, the answer will be W. Differentiate cos, the answer will be minus sine WT. So we went the same. And what I was explaining just now. So this is how to differentiate this. So that at the end of the day, the velocity will be A W cos WT I minus that's going to give us minus A W sine WT. So I'm going to have this is the velocity of the body. Then what about the magnitude of velocity now? Will be the square root of what is the equation of I? A W cos WT, you square it. Then I told you whether it's plus or minus, for magnitude, everything will remain as plus, it will become plus. But if you square everything here now plus, you square it, this minus will change to plus A W sine WT. Then you square it. So this square will affect this A, will affect this W, and will affect this cosine. The square will affect this A, affect W, will affect this sine. So we're going to have something like this. We're going to have the magnitude of velocity to be equal to. Now, A affecting, square affecting A, we're going to have A square, W square, then cos square WT, then plus the same thing with the other one. A square, W square, sine square WT. So WT is the angle. So at the end of the day, we're going to have what is over this and this. A square W square is common between them. So you factor that one out, factor A square W square out. Then what we left to be cos square WT plus sine square WT. Then in trigonometry, cos square theta plus sine square theta will be equal to 1. Must be equal to 1. So as I want to say, I want to say that the same thing will be equal to 1. So cos square WT plus sin square WT will be equal to 1 from trigonometry function. Take note of that. Cos square theta plus sin square theta, or cos square WT plus sin square WT is 1. It's equal to 1. So we have to like this. Square root of a square W square then times 1. That will be square root of a square W square. So this square root, we cancel those squares. Something like this. You have AW, everything squared. This one will cancel this. So the velocity will be AW. That will be velocity. A times omega. That will be the magnitude of velocity. What about the acceleration now? What will be the acceleration of the body? The acceleration will become differentiation of velocity relative to time. And what is the velocity? The velocity is equal to AW cos WT minus AW sin WT J. So it's having G. Now it's in the y axis. So it's having G. It's having G. Then let's differentiate this one out to see what we're going to have. Let's differentiate this and differentiate this. Remember, as far as all this one don't have, there's no T here. So this one, all those two now, they are constant number. They're related to T. So this one now, you leave these two, they are constant. So we already have A, W there. It's already there. This is just there on its own. Then differentiate cos WT. What we differentiated cos WT? What we have? What we differentiated cos WT? We had minus W sin WT. So if I differentiate cos WT, if I differentiate WT, I have W. Differentiate cos, I have minus sin. So I'm going to have something like this. I'm going to have minus, or let me just put it here. Minus, because if you differentiate cos, you are going to have minus sin. If you take WT, you are going to have W, then you're going to have sin WT. So you have to do it. Differentiate WT, you have W, T will disappear. Then differentiate cos, you have minus sin WT. Then minus, then let's go with this. Let's do this second one. Leave this two because they are constant number. WT, that's AW. Then sin WT. Differentiate WT, you have W. JWT, you have W. Differentiate sin, you have cos. Then repeat this one back, this WT. So we have it. So at the end of the day, I'm going to have the acceleration to be minus this one like this. The beta will give you W square. W square sin WT minus A, the beta W square cos WT. So I'm going to have. Then remember, this one is having I, so now it's having G. So it's having I, so now I need to have I, so I have G. So the magnitude of acceleration will be, when you take the square root of the equation of I and the equation of J. Without taking it down to the sign, everything will be positive. You square everything here now, minus is to plus. So we have AW square sin WT square then plus AW square cos WT square. As for WT, everything square. So it's going to affect everything. The other day, I'm going to have, just keep follow me. I'm going to have this A square plus A square. W square, then 2 times 2 gives us W4. Sin square WT. Sin square WT. So take note of this one. Even though you have cos sin, even though sin square WT plus cos square WT, we still be 1. Because sin 1 plus, look at this, even though it's 2 plus 3, 5. 3 plus 2 is 5. We still be 6. So even though it's sin square times 4 plus square, we still be 1. Take note of that. Very, very important. So, plus everything here square give us A square. 2 times 2, 4. Or square WT. So these and these are common. We factor them out. So we're going to have the square root of A squared W4. Then times sine squared WT, sine squared WT plus cos squared WT. So sine squared WT plus cos squared WT give us 1. If you add these two together, you're going to have 1. What we did before. Whether it's cos squared first or sine squared first is 1. And that is plus. So that's going to give us A squared raised to our 4 times 1. That will be equal to A squared W4. So what is the value of A squared W4? That will be same thing as A squared. That is this two. Just remove 2 from this. Remove 2 from this place. Or divide both by divide 1 by 2. So divide 4 by 2 now, you're going to have 2 left. Everything now will carry 2, then square. Then, this one will become to this square, we're going to have AW square. This will be the magnitude of acceleration. That will be the magnitude of acceleration. A square, that is AW square. AW square. So the magnitude of velocity is AW. Magnitude of acceleration is what? AW square. Take note of that. It's very, very important. Very, very important. Then, let's say we have this question now. Let's say we have this question. Let's say we have this question. Another question. The velocity of the body. The velocity of the body is given by the equation V is equal to 3t squared I plus 6tj minus t squared k. T squared k. Calculate the displacement of this body. Calculate the displacement of this body. Calculate the displacement of this body. That's the question. Remember I told you, displacement is equal to integration of what? Velocity related to what? Time. Can you remember that? Now, how do you integrate something? How will you integrate something? Don't have to integrate. You have to integrate. I want to integrate. Let's say I have to integrate now a x raised to n. This one is integration now, not dimension related to x. What will be the answer? What you do, don't touch the coefficient. Just add 1 to the power for polynomials. Then divide both sides by the same power is n plus 1. Then if you are integrating a constant related to x, let's say n shall not have this x, and the other will not be this constant and this x will still be ax. But at the end of the day, you add a constant that we call integration constant. If the thing is indefinite integral, indefinite integral means integration does not have limit, not have upper and lower limit. We have an upper and lower limit. If you evaluate it, the constant will disappear. So if it does not have, if it's something like this now without limit, it will be an integration constant there. We call it an integration constant. Let's call it your C. So remember, when you get a constant, you multiply what you are related to, like when you get it now, A related to x, we're going to have a times x, now give us ax. Then integrate ax to our n, add 1 to the power, then divide both sides by the new power. So we are integrating here 3t squared I plus ctj minus t squared k with respect to t. With respect to t, let me write this so that you see it very well. With respect to t, so integrating 3t squared I plus 6tj minus t squared k with respect to t. So remember, this t is carrying a power as 1. Think of that. Anything that I assume that there's no power on top, there's a power there, is 1. So if you integrate this one now, you're going to have 3. Remember, you don't touch coefficients. What you do, you add 1. This one is t. Add 1 to the power, divide both sides by that same power. Then add 1 to the power, divide both sides by that same power, and divide it by that same power. Add 1 to the power and divide by that same power. So we're going to have. Then at the end of the day, we're going to have 3t cubed over 3I gk. I plus 6t squared over 2 j minus t cubed over 3p plus c. Then, at the end of the day, we'll be having 3, we cancel 3. This 3 will cancel 3. 2 here, 1, 2 here, 3. So we're going to have the displacement to be t cubed I plus 3t squared j minus t cubed over 3k plus c. This is what I'm going to have as our answer for displacement. Then let's look at this question now, and you take it as classwork. Take these questions as classwork. The velocity of a body is given as a function of displacement. The velocity of a body is given as a function of displacement according to the law. According to the law, v is equal to 2s squared. V is equal to 2s squared. V is equal to 2s squared. Let's say I. V is equal to 2s squared I. Find the acceleration of the body. That means the acceleration of the body at a displacement of s equal to 1 meter. Evaluate the displacement of the body. And evaluate the acceleration of the body at a displacement of. Evaluate acceleration of the body at a displacement of s equal to what? 1 meter. So I'm going to solve this one. So acceleration will be equal to what? Then also solve this. Also solve this other one. The acceleration of a body. The acceleration of a body is given by v is equals a is equals to 3t squared I plus t2j minus 3k minus 3k. Obtain the velocity. Obtain the velocity of this body. Obtain the velocity of this body. That is the question. Obtain the velocity. What will be the velocity? Acceleration is equal to this. What will be the velocity? Also solve this. I already if you solve them, you're going to have the following answer. So if you solve it very well, the acceleration is going to be 8 I, remember is having I, meters per second square. Have a second square. The velocity will be t cubed I plus t squared j minus 3t plus c. Remember this one is the integration constant. That is the integration constant. So that is what you are going to have. Please, thank you all. Thank you for the class. Thank you for staying with us. I hope you are blessed. See you guys in our next class, and God bless you. I love you. Thank you.